So what do we do when we have fractions in an equation? If you think back to our procedure for solving linear equations in one variable, the very first step said eliminate fractions and decimals, right? And that's what we're going to do here. Now, theoretically, you don't have to do this. You can just treat that 1/2 and the 2/3 like any other number, distribute it into the parentheses, start adding and subtracting things from both sides. If you do that, you're going to have to do a lot of arithmetic with fractions. It's going to be common denominators and all the rest of that stuff floating around. And if you're comfortable with those things, you can absolutely solve this equation that way. If you would rather not dance with fractions, then I do have an alternative for you. All right, we can get rid of them. And here's how I'm going to do that. I'm going to start by multiplying both sides of the equation by 2. All right, well, why 2? Well, because that's the denominator here of this first fraction. And when I multiply 2 by 1/2, that's just 1. You see what happened now, right? The fraction went away. All that's left on that left side is x plus 1. And what's left over here? Well, if I multiply 2 by the 2/3, that's 4/3 times x minus 4. Okay, and that was good. Yeah, it eliminated one of the fractions, but I do still have that 4/3. And that's okay. I'm just going to do it again. Right, now let's multiply both sides of the equation by 3. And now notice what I did over on the left side. You remember back when we were at the end of the first lecture, and I said I skipped over doing fractions in that one because there are some little details you need to be aware of, and I wanted to be able to spend time and really focus on those. That's one of them. Okay, you're multiplying the entire left side and the entire right side by 3. To make it clear that that's what you're doing, you got to put those parentheses in there. If I had just said this on that left side, that would not have been correct, because it's only the x that's being multiplied by the 3 there, not the whole side. All right, so let's see what happens now, right? I'm going to distribute over here. This will be 3x plus 3, and they cancel here, and I'm left with 4 times x minus 4. Excellent. Now I have to distribute again. All right, let's distribute on the right side. The left side stays the same, 3x plus 3 equals 4x minus 16. Okay, now it's looking really familiar. Let's subtract 3 from both sides. 3x equals 4x minus 19. Now let's subtract 4x from both sides. 3 minus 4, that's negative 1, so this is negative x equals negative 19. And let's divide both sides by negative 1. We get x equals 19, and that's it. Right, there's our answer. Again, you can check these. It's actually not too bad to check these. Both sides come out to integers if you try it, so it's not too bad. Right, that's going to be our final answer. So this is one that really starts to mess doing something. Actually, I'm sorry, I forgot to mention something on that last slide. Remember, I multiplied by 2 and then I multiplied by 3. Okay, and that's fine. If that's how you see that equation, absolutely that'll work. You could have short-circuited the process a little bit and just multiplied both sides by 6. You know, 2 times 3. Right? You multiply the denominators together, multiply by that, and that would have eliminated both fractions in one step. Okay, so how about this one? Okay, here, this is one students often run into challenges with. All right, so here's what I'm going to do. I've got a denominator here and a denominator here. Okay, 5 times 3, that's 15, right? Now, if you multiply, you could do this, you could multiply by that, okay? But if you do, well, there's a pitfall, okay? What I would suggest doing is multiplying all of the denominators together. Okay, so I'm going to multiply both sides by 5 times 3 times 3. That is 45. So let's do that and see what happens. I'm going to do a 45 over here and a 45 over here. Okay, so let's look at the right-hand side first. 3 goes into 45 15 times. So this is 15x. Excellent, the fraction went away. Now look at the left-hand side. 5 goes into 45 9 times. So this becomes 9 times 2/3 minus x. And yes, that 45 is gone. It should be gone. 45 times 1/5 is 9. These two numbers, this multiplication, got simplified to that single number. Now I'm going to distribute. I'll get 9 times 2/3 minus 9x equals 15x. All right, what's 9 times 2/3? Well, 3 goes into 9 3 times. 3 times 2 is 6. 6 minus 9x equals 15x. Good. Now add 9x to both sides. I'm fine with that 6 over there where it is. These cancel. 6 equals 24x. Divide both sides by 24. 6 24. You can reduce that. That's 1/4 equals x. Now remember, we talked about this previously. Please don't leave your final answer that way. It's not technically wrong, but it's really a weird stylistic choice. Turn it around and put the x first. X equals 1/4. Right? And that will be my final answer. Now, what was the issue that sometimes comes up? Let's go back to the original question here, just so I can show you this little pitfall here, so you know what to avoid. I always think, excuse me, it's just as important to tell students what not to do as it is to tell them what they should do. Right? You need to know where the bad paths are as well as the good ones. So what I'll see students do sometimes here is they'll say, well, okay, so they see this 5 on the outside and the 3, and they'll try to multiply by 15. Right? And that's fine. You can actually do that. I'll put a 15 here and a 15 here. Now, 5 goes into 15 3 times. 3 goes into 15 5 times. And there you go. And you're done. Good. You can carry on from here. Right? And everything will be fine. The problem is sometimes I will see students, they try to put this 15 out here, this 15 out here, and they try to slip another 15 in here because they're thinking, not unreasonably, they're thinking the fractions have to be multiplied by the number to eliminate them. Right? But you can't do it that way. Right? What you've done there is you've multiplied the left side by 15. You multiply the right side by 15 and the left side by 15 twice. And that's not allowed. Okay, not allowed. Now here, turns out this is going to come out nicely anyway if you just distribute the 3. If it didn't, multiply both sides by 3. Do it twice, just like we did on the last one, and you would have been fine. So that's how you handle fractions. Okay, how about decimals? Well, decimals kind of have their own little set of challenges. Okay, so that's what we're going to look at and pay some special attention to in the next lecture.